Hello, everyone. Welcome back to the module 4 of software engineering approaches to human computer interaction. Today, we will be talking about sampling. We will see different kind of sampling and how to select a sample size. And finally, we will see some ethical considerations. So, let's start with the big idea. So we almost never study an entire population. Instead, we draw a sample, smaller set of units, so we can infer something about the full population. Um, Two quick terms to learn: the population, which means everyone or everything we care about. So here we can see an example: all US consumers who use laundry detergent, and the sample is the subset we actually measure. So the reason we sample is practical. We have limited time, limited resources, and limited access, but also statistical. With a well designed sample, we can get precise, unbiased estimates without talking to every person in the population. So, uh, the laundry detergent example makes this more concrete. Surveying every user is impossible, but if we choose a representative subset, not just our friends, not only online coupon users, but a properly selected cross section, we can still estimate average perceptions, preference shares, and even differences across groups. So on this slide, you can see there are three nested circles. The population is everyone we want to make claims about, say all the US adults who bought detergents this year. The sampling frame is the practical list we can actually draw names from, like a customer file or a panel roster. So it's never perfect. So some eligible people may be missing and some ineligible ones may slip in. The sample is the subset we finally select and measure. If our frame is credible and our selection method is sound, this sample can speak for the overall population. So, question is, why do we sample? Because our goal is to learn about a target population, but measuring everyone is kind of unrealistic. Instead, we select a smaller group that's likely to represent that population. If the sample is well chosen using a sound frame and selection method, then the patterns we observe in the sample can be generalized back to the larger group. So, sampling is the practical path to credible population level conclusions. Here is the sampling workflow from idea to data collection. The first stage is define the target population: who, where, and when. Um, Next, pick a sampling frame, the list you will draw from, and then decide your method. The probability if you need statistical generalization, non-probability when appropriate, and with caveats. Then write the selection procedure in detail, um, like strata, randomization steps, replacements. um, then compute the sample size based on precision or power. After that, perform the actual selection from the frame, applying any inclusion or exclusion rules. Finally, conduct field work, contact, recruit, and track response so the realized sample matches the actual plan. So, types of sampling, there are many sampling methods. but they can fall into two big families, that is probability sampling and non-probability sampling. We will learn more about those in the next slides. So the main two types are probability and non-probability sampling. We choose between these two. In probability sampling, every eligible unit has a known non-zero chance of selection. So think simple, random, stratified, or cluster sampling. This let us compute margins of error and make defensible population inferences. So we will talk in detail about what each of these sampling means. And moving on to non-probability sampling. So some of the common examples are convenience, snowball, etc. The chances of selection here in this kind are unknown. It's faster and useful for hard to reach groups or pilot work, but estimates can be biased and our uncertainty is hard to quantify. If your goal is population level claim, prefer probability designs over non-probability ones. Now, here are four common probability based sampling methods. We will talk about simple random sampling, random sampling, cluster sampling, and systematic sampling. So, our goal is to pick the design that best balances precision, cost, and field logistics according to specified project. So moving on to simple random sampling. Simple random sampling means every unit on the frame has an equal chance of selection. If we have a list of 500 people, we can use a random number generator to pick. For example, we will select 50 IDs, and that's our sample out of the 500 people. So it's easy to run and statistically clean if the frame is accurate. Two cautions to consider: first, the simple random sampling can miss small but very important subgroups just by chance. And second, non-response can reintroduce bias unless we follow up with them or wait it. When the frame is good and subgroups aren't a priority, simple random sampling is a solid baseline design. Next, stratified sampling. It means we partition the frame into different subgroups, or we can call strata, like gender, region, or age, and then run random sampling inside each of those stratum. So these guarantees coverage of key groups and usually gives better precision than simple random sampling. In the example here, we can see that the company has 800 women and 200 men. With proportional allocation, we sample 80 women and 20 men for a total of 500. So the sample mirrors the population. Two things to remember here: we need stratum labels on the frames. You must weight appropriately at analysis if your allocation of sample is not proportional to your original population. Next is cluster sampling. Cluster sampling selects group first. For example, schools, clinics, offices, then surveys everyone in those clusters or a random subset within each. It's ideal for large geographically dispersed population because it cuts travel and cost. So, in the example here, instead of visiting all 10 offices, we randomly pick 3 offices as our clusters and collect data there. So, one thing to remember, people within a cluster tend to be more alike, which lowers precision. Plan for a design effect. It's usually better to sample more clusters with few people in each cluster than taking, more uh, people and less clusters. Systematic sampling means we select participant at a set interval starting from a random point. The advantage is that it can yield a representative sample. The downside is it can be difficult and resource intensive. For example, from a university list, start at a random student, say ID number 40, and then take every eight students starting from 40, like 48th, 56th, 64th, etc. Moving on to non-probability based sampling methods. Um, so this list is not all, these are just the most commonly used one. We will look into purposive sampling, convenience sampling, and snowball sampling. So researchers often use these samplings in their studies. Purpose sampling, also known as judgment sampling, which means we intentionally choose participant who best serve the study's purpose. It relies on clear inclusion criteria and a stated rationale for why these cases matter. You will see this often in qualitative research. For example, if we want to understand the experiences of disabled students with support services, we would purposefully select students with different support needs to capture a range of perspective. Next, convenience sampling selects people who are easy to reach based on availability or accessibility rather than a formal random process. It's quick and low cost, which is why it's common when time or resources are tight. For example, after class, you want to survey the students who happen to be there. That's convenient, but it isn't representative of all the students. So findings may be biased. Use convenience sampling for exploration or pilots, but be cautious about generalizing to the whole population when you are using the convenience sampling. Snowball sampling builds on the sample through referrals. We start with a few initial participants and ask them to recommend others who fit in the study. This is helpful for hard to reach populations where no good list exists, but the trade off is that it's unlikely to be representative and can reflect researcher or network bias. People tend to refer others like themselves or their friends. Um, for example, studying experiences of homelessness, we began with one participant or two participants when then they connect us to others in their network. So it's often practical, but we should be careful about generalizing the result for the whole population. So, important question is how do you know which sampling method is right for your research or your product? So, choosing a sampling method comes down to two key things. First, your research aim, and then the available resources. So, you start with the aims, that questions do you need to answer, and what level of generalization or subgroup details do you need. Then look at practical constraints, time, budget, access, and recruitment. If you have strong access and funding, you will have more options. If not, you may need simpler approaches, except trade offs, precision, and generalizability versus cost and feasibility. Always align the method with the aims within your constraints. Now, sample size determination. So, how many participants do you actually need? Um, and how many participants do you need to make your results trustworthy? So, the purpose is to secure enough observation for statistical significance and precision matched to the aim and scope of the study. There is a clear trade off. For example, a larger number of participant improves accuracy, but it also raises the cost and complexity of your data. And on the other hand, a smaller group of people is easy to reach. They're cheaper, but there is always a risk of underpowered or imprecise findings. So our goal is to pick the optimum number of participants, but big enough to answer the question well, but realistic for our resources. Sample size planning depends on the type of outcome. First, for binary outcome, yes or no, vaccinated or not vaccinated. For these kind of results, we work with proportion. Secondly, for multi-category outcomes like marital status, blood groups, um, we also think in percentage or rates across several categories. For both of these, we size the study around the percentage we accept to observe. And finally, for continuous outcomes like birth weight or blood pressure, we plan using means and standard deviation. So the rule is percentage for categorical data, um, means or standard deviation for continuous data, and we choose the sample size accordingly. Next, there are a few ethical considerations to remember. Our duty is to protect our participants' honor and honor the study's purpose. Build a relationship on trust and clarity. Explain what the study is about, what kind of data you will collect, and how it will be used. Um, there are few points, 5 points of pattern that kind of provides checklist for ethical considerations. First, the reciprocity, risk assessment, confidentiality, informed consent, and data access and ownership. Um, Incentives are optional, but if you consider giving incentives, offer fair, non non like non coercive compensation, disclose the amount and conditions in the consent form, keep it equitable across different groups, and secure IRB approval and watch for incentive related sampling biases. Finally, you should be ready for emotional content. Participants sometimes may share sensitive experiences, and researchers should plan support and different referral options. So that's all for this slide. Um, I will see you in the next module.